In this video we will see how to extract the sensory canals in this lungfish fossil, Gononasus lungfish fossil. I got this dataset from Gavin Young here at the Australian National University. So what we would like to do is now extract these sensory canals. So let me just make them much a bit more clear. So these are the sensory canals here. These are the canals that we would like to extract. These ones here. And these ones. So let's go into so this is the fossil here, lungfish fossil, Gononasus lungfish, and we would like to extract these canals. So that's the canal that we are interested in, and that comes right to the front here. Now we will modify the transfer function so that the canal is has higher contrast. So we are basically playing with the contrast here. So this is what we want to extract. So let me just flip using F. I have just flipped the color gradient, and let's go up to this point here. Okay, so we can go right, so it's probably here, so we can, so let's mark this region. We are applying color for tag 1, so press T, and here press T. Let me just make this bigger. Press escape to remove this marking here. Okay, now we can start applying this tag. So press Shift T for multiple slices. Shift T. Let's go backwards first. Now we would like to, now this is going off track, so let's just reset backwards. It's going well off track, it should not go there. So what we can do is we will increase the contrast. So let's just increase the contrast here. So I've now increased the contrast, and then we can start again. So let's start here, say tag, and then we can probably set box size to 10 or maybe 5, 7, just increase that, and lambda is fine. Tag here. So we are right at the end, and then we can start tagging. That should be fine. Tag here. We can just add in a bit here. Press escape, just go back, tag. No, we don't want to go there. Okay, we can again increase the contrast here. Shift T and then forward. Okay, now we can stop here and we will come back and fix this thing. Let's just go on this side and then tag, and if we cancel, what I can also do is I'll just set that as a background. Okay, tag forward. Let me press escape, stop that, and what I'll do is I'll just change, you just add a bounding box, so using alt and left mouse button, and then start the procedure, and it will go much faster because now it has to operate only on a smaller region here. Okay, stop here, double click, let's go back and let's start the process for this channel here. So this is the other channel. Press tag, okay, press escape, and then again we are going to just limit the process so that it goes faster. I'm just dynamically updating the, okay, stop, and then we can go back here. Okay, so make this bigger and then start the process again. Stop, and we just increase this box, just go back a bit. Stop. Okay, now this is also part of that channel, so let's put a dot here, tag, press escape, shift T, and let's go backwards, meet the other part, and then we'll come back again. Okay, so it has met the other part, this one here. Now let's go forward. Let's start the process again, shift T, forward. is this box? So this side is almost done now. Stop. So reset, 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 and let me just increase it to 15. Tag, tag. So it's almost done here. Now let's go to the other side. So this side here, you can start the tagging process from here itself. So tag, and let's go forward and then afterwards we can just go backwards. Okay, and I think this channel probably goes on that side here. Yes, so this channel continues here. So we'll put a tag here. Skip tag. So tag. Tag forward. Now because the lambda is 15, it's not escaping this empty channel here, and it's still more tightly bound to the original seed. And it's almost done here. Now we can go back and then start the process again. So we'll go back, tag, so this is the connection between the two channels here. Observe that because of the lambda it hasn't escaped. Okay, so now we can start going backwards. So using Shift T, I can apply the process over multiple slices. I'll just make the bounding box smaller. So at the end what we'll do is we'll just dilate this a bit so that we can get the boundary of the channel, and so when we view that we'll also see the boundary of the channel as well as the interior. Now observe that this has become mostly IO bound job, because what it's doing is it's reading the slice, applying the tag, and then putting it back onto the disk. So there is a lot of disk IO going on there. So let's stop here and let's try to find the other tag. Yes, so it's here, tag, a bit more, tag, so there's some loss here which we can just use this and then make the connection. So applying tag and then no, this is a strong one, so tag, escape, and then we have made that connection here. Okay, let's go back and start tagging forward. Let me also reduce that shrinkage. And forward. Again we are losing here somewhere, and then it picks up here, tag, go back, tag, okay, and then we can start pushing it forward again. Let's reduce that further. What we'll also do is reduce that lambda from 15 to 10. Now here we again, I'm just resetting the tag because it has gone off track. So I'll reset that, reset backwards. Okay, reset backwards. This is fine. Let me put it back to 15. And then let's add here tag, skip, tag forward. Okay, now we have to find, so this is where it disappears, and tag. And it fights that, yes. Okay, so I think we are almost done here. Okay, now we'll extract this tag. So extract tag region, tag number 1. We'll just apply some dilation, let's say 2 voxels or maybe 3 voxels. We are extracting image data, and then let's call it, say, channel. The whole process has probably taken 15 to 20 minutes. So we are applying dilation over the region before extracting the data. So your tags data is going to be dilated, and then that will be used as a mask to extract the image data. So now that we have extracted the channel, let's see the channel. Yeah, so drag and drop the channel. So this is the channel that we have extracted. Let me just take that here, press F2. And now then you can say make a mesh, or you can then go and find a volume, or you can also apply some smoothing to make it look better. So this is the channel. So we can extract say channels or specific features within a fossil.